The universe is vast. It is full of wonders. NASA has shared something mind-boggling. They hinted at another universe existing alongside ours, a whole other reality potentially connected to ours. This idea is sparked by new perplexing data. The James Webb Space Telescope is the source. It peers deeper into space and time than ever before, designed to uncover the secrets of the early universe. And it has been doing that spectacularly. It may have stumbled upon something profound. What does this mean for us? We might be on the verge of a paradigm shift, a change in understanding. Like Copernicus, this discovery invites us to be humble. Let's explore what NASA has found. The James Webb Space Telescope, or JWST, is an engineering marvel. It orbits the Sun far beyond Earth, its giant golden mirrors collecting faint light from the dawn of time. Its purpose is to see the unseen, to capture images of cosmic objects that are incredibly distant and incredibly old. Recently, the JWST detected something truly peculiar. It observed a structure, an object, or perhaps a phenomenon that doesn't quite make sense. This isn't just another distant galaxy or an unusual star. This is something that behaves in ways that our current laws of physics cannot easily explain. The object's characteristics, its light signature or its gravitational influence are setting off alarm bells and sparking intense debate among researchers worldwide. The details are still emerging as scientists meticulously check their data and run simulations. However, the initial reports suggest this structure is enormous, possibly on a scale that challenges our models of cosmic formation. More puzzling is its interaction with its surroundings, or perhaps its lack of expected interaction. It seems to follow a different set of rules. This discovery is not a direct photograph of another universe, let's be clear. It could be a sign, an imprint, or even a gateway to another. The James Webb Space Telescope, or JWST, is an engineering marvel. It orbits the Sun far beyond Earth, its giant golden mirrors collecting faint light from the dawn of time. Its purpose is to see the unseen, to capture images of cosmic objects that are incredibly distant and incredibly old. Recently, the JWST detected something truly peculiar. It observed a structure, an object, or perhaps a phenomenon that doesn't quite make sense. This isn't just another distant galaxy or an unusual star. This is something that behaves in ways that our current laws of physics cannot easily explain. The object's characteristics, its light signature or its gravitational influence are setting off alarm bells and sparking intense debate among researchers worldwide. The details are still emerging as scientists meticulously check their data and run simulations. However, the initial reports suggest this structure is enormous, possibly on a scale that challenges our models of cosmic formation. More puzzling is its interaction with its surroundings, or perhaps its lack of expected interaction. It seems to follow a different set of rules. This discovery is not a direct photograph of another universe, let's be clear. It could be a sign, an imprint, or even a gateway to another. So, if this strange object isn't playing by our universe's rules, what rules might it be following? This is where a fascinating, though highly speculative idea comes into play, the mirror universe hypothesis. This theory proposes that our universe isn't alone. It suggests that there's a twin universe, an almost perfect reflection of our own, but with some fundamental properties flipped. Think of it like looking in a mirror. Your reflection looks like you, but your left is its right, and its right is your left. It's a familiar yet subtly altered version of reality. The mirror universe theory takes this concept to a cosmic scale. In this other realm, some of the basic constants and particles might be different. One key idea is that antimatter, not matter, would be the dominant stuff. In our universe, matter, protons, electrons, makes up everything we see. Antimatter, antiprotons, positrons, is rare. In a mirror universe, this could be reversed. Stars and galaxies there might be made of antimatter. This is a profound difference, with significant implications for how such a universe would evolve and what it would look like if we could somehow peek inside. Rethinking reality, the fabric of space and time unravels. The mere possibility of a second universe, especially a mirror universe, forces us to re-examine our most fundamental concepts: space, time, and reality itself. For so long, we've considered space to be the ultimate container, the three-dimensional stage on which all cosmic events unfold. But if another universe exists, is it somewhere else in our space? Or does it occupy its own distinct space, perhaps coexisting with ours in higher dimensions that we cannot directly perceive? This challenges the very definition of here and there on the grandest scale imaginable. Then there's time. We experience time as a forward flow, a relentless march from past to present to future. Cosmic conversations. Our universe is interacting? If another universe, a mirror universe, truly exists, the next big question is, are we isolated or is there some form of interaction? The strange object detected by the Jwst might itself be evidence of such an interaction. Perhaps it's not fully in our universe or in the other, but rather at an interface, a place where the two realities touch or overlap in some way. This is highly speculative, of course, but it's a possibility scientists must consider when faced with data that doesn't fit existing models. The nature of such an interaction is a complete unknown. What could an interaction between universes look like? It might not be dramatic, like a portal opening in space. It could be far more subtle. Perhaps there are slight gravitational anomalies that we can't explain with the matter we see in our own universe. Dark matter, that mysterious stuff that makes up most of the matter in our cosmos, could even have connections to a mirror world. The next frontier, charting a course for new discoveries. The hint of a second universe, possibly a mirror one, is just the beginning of a long scientific journey. Confirming such an extraordinary claim requires extraordinary evidence. The first step is for other telescopes and research teams to try and observe this strange object found by the Jwst. Independent verification is a cornerstone of the scientific method. Scientists will be pointing their most powerful instruments at that patch of sky, hoping to gather more data to see if they observe the same anomalies and perhaps uncover new details that were initially missed. Beyond observing this specific object, scientists will also be re-examining existing cosmological data with this new possibility in mind. Are there other unexplained phenomena in the vast archives of astronomical observations that might fit the mirror universe hypothesis? Perhaps subtle patterns in the cosmic microwave background radiation, the afterglow of the Big Bang, or unusual distributions of galaxies could hold further clues. Theoretical physicists will also be hard at work, refining models of mirror universes and predicting other observable signatures that experimentalists could search for. This is a collaborative effort, spanning many disciplines. Beyond our horizon, embracing the unfolding mystery. So, we stand at a fascinating juncture. NASA's announcement, fueled by the James Webb Space Telescope's perplexing discovery, has opened a door to a mind-expanding possibility, the existence of a second universe, perhaps a mirror image of our own, where antimatter dominates and time might flow backward. This isn't a confirmed fact, not yet. It's a tantalizing clue, a cosmic puzzle piece that doesn't quite fit the picture we currently have of reality. But it's a clue that demands our attention and our most rigorous scientific investigation. This potential discovery challenges our deepest understanding of space, time, and the very laws that govern existence. It suggests that our universe, vast and wondrous as it is, might be just one part of a much larger, stranger, and more complex cosmic tapestry. The implications are staggering, touching upon everything from the nature of matter to the arrow of time and the ultimate fate of all that is. It forces us to confront the limits of our current knowledge and to embrace the profound mystery that still lies beyond our scientific horizon.